trying to get all those challenges solved. And without wasting any time, I'll give Caspar to do the house rules and allow Dr. Host to do the presentation. Thank you.
Thank you so much, Kabelo. Welcome everybody to today's session. We hope you enjoy it. We only have a few small house rules for today. We'd like to ask everybody to please mute your cameras to save data and bandwidth. Also to mute your microphones to keep all the background noise to minimum. If anybody has a question at any point in time, please feel free to raise your hands, and there will be question and answer sessions. And then over to you, Dr. Host.
Awesome. There we go. Oh, I see there are other people coming in, so that's awesome. All right. Where's my camera? There we go. Okay, so for all those who are here with us, it's session number 4 already. Excellent. And well done for staying with and joining us. And so today we're doing something a little different because we've done the building of the basic chassis, so the basic robot body. We have done some programming just to make it actually move. And so we've shown you how to make a robot move forward and backwards and left and right. And so we've done all the navigation parts. And then we did some problem solving yesterday, which is the 21st century skills that come between engineering and programming. But what we're going to do today is kind of the next step. So if you have a, I'm just wondering what this is on here. And that's where I built a little wheel and I knew I put it down somewhere. That's where I put it. Okay, so if you've got a chassis, it depends what your chassis looks like. This is obviously after years of experience. And that's not where you start. You start with a robot like this, a little robot like this. And so we have different bodies of robots. And you'll see also when you look at the building instructions, there's different designs. And remember, I said we're just doing motorized. We're just doing the little motorized robot for now. We'll build all the funny things and the weird things and the arms and the humanoids later. But for now, just this robot. And this robot can go forwards and backwards. And so, so there's now a next step onto building onto this robot, okay? And the funnest part is when you give your learners a challenge and you tell them to solve the challenge, but it needs them to build something as well. So if you look here, this robot is quite far from the ground. So if you have, and I often use sweets because sweets gets kids motivated. So if you put a whole lot of sweets down and you've got to go and fetch the sweets, well, the robot can drive to the sweets, but it's going to drive over it because there's nothing here to push the sweets. Okay. And then it's going to, so I always say, well, what would you do here? You would probably build something in front, like a bumper. Okay. So all the attachments that we're going to discuss today are all passive. In other words, they just add to the structure. You're not programming it, and we'll come maybe in 2 weeks' time, we will then do powered attachments, and you'll see powered attachments are the powered attachments are the attachments that we program. Okay, today we're only doing passive attachments, and so let me give you an example. So here is I need this robot Mario because I've got his passive attachment. You'll see in the front there are holes there. And round the frame, there are holes there. So we use all these holes to connect passive attachments that we might need. So, for example, this robot needed to push something, and we needed kind of I said something like this. And so the team built me this and said, okay, this is a passive attachment because it just attaches onto the front of the robot. I'm just going to say, so it actually fits in like that. Let me just put it down like that. There we go. Okay, so you can click it in. It clicks in, and there we go. There's a passive attachment. So now you can push something. And when you come back to base, when you're allowed to touch your robot, then you just can take it out. And you see it's got the pins in it there at the bottom there. So it fits in. It fits into there. Okay. It doesn't, by no ways is it, you're only using your navigation programming. You're not doing any other programming. You're just doing navigation programming. And then you're adding this structure to your robot. Okay. I do want to add though, and this is kind of an aside, that the building of all these attachments, there's no manual for these things. All right, so you need your learners to engage and say, what do you need to do? Do you need to push something? And this is where drama, or does it need to go like this? Or does it need to plow through something? Or does it need a barrier like that? Or does it need to hold like that? Okay, and if you can answer that question, well, then you can build it. All right, but in that sentence, there is a gap, because our learners don't have design, okay, and they don't have ideas in their head. So what we need to do is we give them building instructions to build a whole lot of attachments to create a frame of reference. Okay, so they will build something and then they modify it. So for example, for this one, initially it was just two little things like that, and it just pushed something like that. Now the object that they had to push was bigger, so they have to adapt, and you have to adapt designs. And so with passive attachments, that's what we're doing. We're adapting that which we have learned. Okay. So another passive attachment is this one. So I don't know if you can see. So this was, from the side, it looks like just the general structure, and there's that same attachment. But then they put a gate on it. So if the robot goes forward over the thing, over the object, it goes forward, and then it falls down. And so when it pulls back, then these are the locks, okay, that prevent the stuff from coming in. There's like a, it's called a gated cage. You can call it whatever you like, what this design was. But this design didn't always look like this. It was actually much narrower and taller, because it had to actually obviously whatever object you're trying to get, that's got to be that height. See, this is where the design comes in. You think, oh, how are we going to change it? This was to collect a lot of things scattered on the ground, but quite flat. So then it's got to be wider. Okay. If you want to, I don't know, get something that's taller, what is taller? A cup. Okay, then it'll have to be higher, and the gate will have to be higher, and maybe not so wide. All right. So this is what this, and I'll give you some examples now in the presentation. This is your frame of reference, okay, that we're building for our learners. We are building it as coaches, and I'll give you some examples. So this was, you had to deliver a whole lot of marbles to a specific spot. All right, now you try and deliver marbles with this thing, okay, then you've got momentum. So you push the marbles to a space, and then you reverse, and I can tell you those marbles are going to roll all over the place because they have momentum. Okay, so the team came up with this idea. So they put the marbles in there, and then they just pushed this whole container with the marbles. So that, again, that's a passive attachment, because if you look like this, there goes the robot, there's your marbles. It just pushes it and then goes back, and it leaves the marbles where it needs to be. So that's, again, a passive attachment. It's not programmed or anything. Okay, so let me give you some examples of passive attachments. And I want you just to think, how can you modify it? How can you do it? And I'm thinking there's another, I'll find it now. There's a really cool book on contraptions, and I'll get those books out my bookcase now. And it starts with just little projects. So before you start your robotics class, get them to build a little gadget that goes up and down, or actually, I'll get you my other thing now after the presentation. I build little contraptions with gears and things. It's to get your learners to think, how can we do this? I also just want to add that if you get a team that designs something really amazing as an attachment, put it into Lego Digital Designer so that you keep that design. And so what we found over the years is also learners then build this amazing attachment, and then they use it for multiple purposes later. They've got this their own attachment, and then they just modify it as they go along. All right, so let me go through the presentation, and then I'm going to, it's a normal question. Can you see my presentation? There we go.
We're waiting for it to come through.
I'm also waiting for it. There we go. Okay.
Yes, I can see this presentation.
All right. Okay. So we're on Unit 4 already. Well done. Well done. And so for everybody who's here, whether you're in class today with us or whether you're watching this recording, thank you. Thank you. Thank you. Thank you. Yes, now we're the end of Unit 1. Now we can move on to Unit 2. But so what we're doing today is the focus is passive attachments, and there is an engineering design process. And sometimes with the process, you want to say, okay, what's step 1? What's step 2? There's step 1 and step 2, but often you'll find the team members will go in little circles around, until they get to a solution. So here we are, Unit 4. This is again our navigation information. And so Tumelo and Anzani are in the mailbox, and they're really keen to help you. If you have any problems accessing the MOOC portal as well, Tumelo has already guided many lost MOOCers. Is there a word like that? A MOOCer? I don't know. Okay, otherwise we're going to have to create a word. Okay, but this is session 4. You've managed session 4, and if you can do 4 sessions of M1, well, the challenge is, can you do 4 sessions of M2? Then that's just awesome. All right. And this is our culture of asking questions, ask, because if we have competent and confident learners, we need to ensure that our coaches are competent and confident too. All right. There is a journey. There's a journey that starts now, and please do not think that you've arrived, because you're going to keep learning, and you're going to keep going beyond what you think you know to something maybe you didn't know. Okay, and so we're building with the robotics kit, and we're programming with the software. We just with motorized robots, but there's all this 21st century skills that you need to develop in the process. All right. So Unit 4, first and foremost, is about an engineering design process, and then we use the engineering design process to build passive attachments. Okay, the powered ones we're going to do in the next MOOC. When you look at the overview document for M1, there's quite a detailed discussion of the engineering design process. Okay, so you need to be able to know the steps of the engineering design process. Remember, we're trying to get learners to think beyond. So it's not just a hit and run. It must be kind of a structured approach. There are steps in your engineering design process. There must be evidence that the team knew what they wanted to do, that they considered other examples, they maybe modified other examples. So you've got to find examples, discuss in your team, what are the risks, how can you change the design. Remember, we're designing it, and then we have to actually make it. Okay. So we have 7 objectives in Unit 4, and these are the 7 most, it's like frequently asked, most used passive attachment. So the bumper, where it's straight or V or inverted V, is the plow. The delivery box that I showed you, the motion trigger, I'll show you an example now, the box and trap, the sweep, the hook, and then the carabiner. The carabiner is that thing that hooks, like when you're climbing a mountain, for those who've climbed mountains, that hook thing that doesn't release. So you have to, there you have to build it. Okay, so you have to build the stuff. So there, from the engineering design process, you've got some building objectives. Okay, so you have to build them. And then you actually have to have programming objectives. And so you need to be able to push with it. So you look at the verb, you push, you dump, you collect. So there's verbs involved. And this comes back to when you do problem solving, you look at the verb. Okay, and so then you look at the verb, and then you come back to, so what is the attachment that we need? Right. And then I've included some activities where you need to build and program. So you need to have, like, push with the bumper. So you can push different things. And if you push with the bumper, so some things are so light, you can just push them, and other ones you can't. And then you can change the surface. So get like that Astro, that fake grass, or you can try and do it on incline. That's a lot of fun if you make a ramp. Those robots sickle up the incline, and then push something as well. So the delivery box also maybe it mustn't touch the wheels, but it must be able, the robot must be able to push it without losing it as well. The motion trigger, I'll show you now what that is. And that's just a on a pivot point where you can dump something or drop something. Okay, the box and trap, the trap must actually enclose the items. So that is kind of with a gate, which the example that I showed you, that's kind of a trapping. It's a box with a trapping. And then the sweep is you sweep up things, and there's lots of different ways of designing that. But you've got to start with a basic design. The hook with a hook. So the robot has approached these things that you're going to hook very slowly, but sometimes, if you only have a single hook to hook something, the probability of being successful is kind of reduced. So if you have a hook with multiple hooks, then you can kind of pick them up quicker. And then the carabiner. Okay, the carabiner is usually hooked, so it goes over, and I'll show you how that works as well. This is Tumelo's MOOC portal, and I'm going to give him a time to chat with you just now after the presentation. I think I'm going to do both presentations. And then we can, oopsie, wait a minute. There we go. All right, I just need confirmation that you can see my engineering design process. Yes?
Yes, I can see your presentation.
Thank you. Thank you. Okay. So the engineering design process is, number one, it's a process, and number two, you're designing. Okay, so there's an overview there, but it's known as the technology process, or I don't know what all. So it's all into that. It's a process, and I think the 5 most important steps are really to be reviewed. So if you have a goal, you ask, so what is the problem? Okay, what do you actually have to do? And you understand what you have. Don't overthink the problem. Just understand what the problem is, and is there any reason where the other people have used it? Okay. So what are some of the solutions? And then you brainstorm the ideas and you choose the best one. This is made a little bit easier because there are actually teams that love sharing their ideas. So we really need to develop this culture of sharing our creative ideas. And yeah, you either make a video of a really cool attachment you made, or you can put it into Lego Digital Designer so that you've got some record of it. Okay, well, then you've got a plan, your door drawings, make a list of what you need, and then you obviously need to create it. But whatever you create, you've got to test. And I suppose this is where the graciousness comes in. If it doesn't work, then say so. If it could be better, then say so. And you can modify it. There's no, to modify something is actually good. It's really good to fix something. And so really here is the thing. And if it doesn't, if you improve it, then you can go around and say, well, does it address the problem? If it doesn't, can we think of another solution? Yeah, so you've got to be honest here. All right. So when we design the attachments and, of course, the robots, we need to have a kind of first a robot, and then we have these attachments, but they can be modified. Nothing is cast in stone. If you read the building instructions for a bumper and it's too big, then you make it smaller. Okay. If it's too wide, you make it narrow. If it's too high, you make it lower. Yeah, there are those options. This is the Lego Digital Designer. There's a lot of material on it, how to design things. I know it's just easy just to get on and just make it. But maybe I think the Lego Digital Designer is more important if you have something that is really awesome and you want to keep it. I have many attachments lying here that my teams have made over the years, but they've been used for multiple purposes. So they don't actually deconstruct their attachments, they modify their attachments. So everything gets modified as they go along. All right. Okay, so this is my frame of reference, my book of reference. And this is the book for the EV3. I'm not sure whether there's one for Spike Prime yet, but there was one for the NXT, and I started with the NXT in 2009 already. But it's very insightful because this is the first time that it was actually laid out that there are passive attachments and then there are powered attachments, and best you understand the difference between the two. I do think this book is available as a PDF somewhere on the internet though. All right. So this is my other little bookie. And it's Lego ideas. And I'm just going to turn around and see whether I can. There we go. I'll show you this after the presentation. A really cool book. Although working with children, I don't know why the book has got a white cover, but a lot of really cool ideas, 181 of them. Okay, so you can make a contraption a day for every day of the school week. So it's like really cool. But I've got other books as well that I can show you as well. Again, to create this frame of reference. Okay. So why do we need attachments? Well, if you have a robot, it's got to do things. There's verbs. So it's got to push, pull, collect, deliver, drop, fetch, and then what does it have to? So now you add a attachment to add function to the robot. But it must be easy to exchange the robot. And so we're dealing with passive attachments in M1, and then we will unpack motorized or powered attachments in M2. All right. So usually the attachments are clipped onto the larger chassis. There was a time when it was a really tiny robot, and then there was this huge attachment. I think that era has passed because I don't know why. Yeah, I'll tell you later. But the passive attachment, there's no additional programming required. So it's just our navigation programming that we've had in Unit 2 and 3, just straightforward navigation programming. If you have powered attachments, we need to do additional programming. And there's a really cool link for you to watch if you want to understand those two. All right. So let me introduce some passive attachments. Remember, no additional programming. It must push, pull, there's verbs, and it must be easy to attach to the chassis and it's easy to remove. And so examples are the bumper, the plow, the container, and the hook. So let me give you some examples. But first, if you follow building instructions, they're very clear task. The learner knows exactly what to do. It's fast, it's straightforward. You can use existing knowledge, and it expands the learner's knowledge. Okay, but if you use building instructions, it's kind of not my design, and it's kind of not really suitable for the attachments. That's fine. What you're doing is you're creating a frame of reference. Okay, you always want to get over to the exploration. The exploration says we kind of are creative and problem solve, and it's our product, and we can expand our creativity. It requires a lot of time from the learners, and it also requires a lot of patience from you as a coach. All right, because it might seem that your learners are wasting time. So just bear that in mind. If they want to try something, just to test something, it might take a while. All right. So this is a trigger attachment to drop. So this trigger, if you look down the bottom here, where's my thing? There we go. There's an axle, and so underneath this ledge, there is a pivot point, and it's there. That is your lever, and so when it goes forward, it's going to move forward. That's going to touch the side of the bucket, and then the ball is going to fit or fall into the bucket. Okay, so that's just a straightforward trigger attachment. This was kind of what I showed you, was another example of what I showed you. So if it goes forward, it will then gather the bricks in front of it. So you can push or deliver something there. It'll stay there, and then you can move back. Or you can go forward to collect something and then turn around and bring it home again. That's the same attachment. And then what you can do to that one is you can add the gate on the front, and that'll keep those things. This is the NXT robot. It's a really zhushed bumper. I don't think you really need to have it's even got a touch sensor there at the bottom there to say that you've bumped into something. Very creative design, but not very colorful. But anyway, yeah, but functional. All right. If you wanted to pick up a whole lot of sweets, it would not be a good idea. Why? Because the sweets are going to go under the bumper. And so that doesn't really make sense. Okay. So usually what you do for a bumper is you add side guides kind of to guide whatever you're pushing. All right. So there's a whole lot of online attachments, things. There is some great attachments for your competition robots as well. I think I've said this every time I do this presentation, this modular test vehicle was an NXT robot, which is like all different parts, and it all fits together. And it's a really great example of passive attachments of different parts of the robot. Yeah, maybe I'll sit one day and change it to Spikemark. I'll see one day. Okay. But yeah, that's the end of Unit 4. It's really great. Well done for being with us. But you need to build attachments. You need to find examples and build attachments. And there's lots of building instructions, okay? But in the overview, there are 7 building instructions. Try and build them. Try and find building instructions for them, or just add them to your robot, and then submit the portfolio. And I would really appreciate if you could complete the evaluation of the M1. We use that information to zhoosh up every year the MOOC portal. And so we usually go offline at the end of November, and we come back on the first week in February. Yeah, implementing different ideas, seeing what works, what doesn't work. If you'd like to add something, if you'd like to be a contributor, will you please let me know? Yeah, it'll help. Yeah, we're a community here, and so we work together. All right. And so that is the end of this presentation. And I just want to know, are there any questions? Are there any questions that anybody has? Oh, my camera was off.
There's a question from Angie.
Okay. Hi, Angie.
I'm so faithful to ask questions.
Go for it.
This is now maybe a stupid question. You might all laugh at me, but I was just thinking now, this training is obviously specifically for the coaches and that sort of thing. The portals and the tests that we're doing in the building, is that now just us learning, or is that what you're wanting us to implement with our teams?
You see, here's the cool thing. It's your learning. But if you need to teach your learners and get them to help you with the portfolio, then it's a learn-learn situation.
Okay, so ideally, I must try and do it before I get them to do it.
Yes. Yes.
Okay. All right. I just wanted to make sure.
But you can also use it in your teaching, Angie. You're welcome to use it in your teaching.
Okay. No, it's just because I'm still struggling. I'm struggling to get my head around how I implement this with the kids that I'm going to be working with, because obviously I need to know where to go. But I mean, that will probably sort itself out as I get onto the site and work with all that stuff.
Correct. So under normal circumstances, if I had a class, I had as many minutes as they're old. So I usually worked with 10-year-olds to 12-year-olds in the primary school. So I had about 10 to 12 minutes to tell them what we were going to do. And it was always on a Friday afternoon. It was the Friday afternoons are just when you are so tired and you are so finished, and then you stand in front of a class and then you do a robotics lesson. So what we would do is I would say, okay, today we're going to build passive attachments. We're just going to do the bumper, and it needs to be something like this. Okay, so then they all build something like this. And then I say, okay, now we have to attach it to the robot. Oh, so okay, now we attach to the robot. I said, okay. So that's the seven building objectives. So you do the first building objective. Then you say, cool. Now we have to program it. So I put 10 chocolates down there, and I say, all right, you've got to, only with a bumper, you've got to go forward, fetch your 10 sweets, and come back. And the one who gets the most sweets in the quickest time, that's the winner. And then I leave the class. Then I've done my 10 minutes of talking. I've told them I walk around the class. It's not that I like, okay, over to you. And I have mentors for each group. I have a mentor. Yeah. And then we spend the whole hour trying to get these robots to bring back the sweets with a bumper. Sweets is better with a plow. Okay. No, not a plow. Plow is like this. Yeah, whatever. This bumper. And then the words are still in my head. And then we, after an hour. So if you have a 2-hour session with your learners, all right, the 1 hour is solidly just them trying to figure out how to do this. Half an hour beforehand, the kind of introduction, and the 10 minutes that I get to talk. And then half an hour late after, they need to be able to explain what they've done and what works and what doesn't work without saying thingy and other thingy. And so there must be a time of sharing, and learners need to learn to stand up confidently and explain what they've done in the class. And then there always needs to be a cleanup session, because guaranteed the learners will get their moms and dads and everybody to come and fetch them before the class ends. And they're like, bye, ma'am, we're off. And you only need to get caught once with a class full of unfinished robots and laptops where the software hasn't or the programs haven't been saved. No. So before anybody leaves, it needs to be tidy. They need to tidy it up. They need to shut down their robots. They need to make backups of their programs.
Okay, awesome. Thank you.
So in the seven passive attachments, you've got 7 lessons. Okay.
Great, thanks.
So I just want to show you. I just want to go fetch 1 minute. Let me just go fetch something quickly. Luckily, I know where it is.
By the show of hands, can I kindly please see who's not registered yet on the MOOC portal? Just by the show of hands. I am seeing Tepo. Tepo is not yet registered. Who else is not registered? Okay. Mavandla, Gladness. Who else also is not registered on the MOOC portal? Okay, I've got 3 participants who are not yet registered on the MOOC portal, as well as Anzani. So in the meantime, what I'll do, I'll just show you how to register yourself on the MOOC portal. So simply go on this link, which is mooc.unisa.ac.za/portal. So you will see here underneath the UNISA logo is written welcome, how to register, site browser, as well as new account. So you click on new account, then you create your own user ID, your first name, your last name, your email address, as well as your passwords. From there, when you are done, you go to, you insert your user ID here on the top right, as well as your password. From there, you click on login. After clicking login, this is the first page that you will see. On this page that you are seeing, just underneath the UNISA logo, down there on the tabs, there is overview, profile, as well as membership. You will click on membership. After clicking on membership, this is the page that you will see. Just next to the UNISA logo again, it's written membership, my current sites, my official course enrollments, as well as joinable sites. So now, because you are new on this, you will click on joinable sites. When you click on joinable sites, you will look for ISET Robotics M1 2022. And then this is how you look for it by scrolling down. So let's say, for example, you have found it, you will click on join. After clicking join, you will have to go back to membership. After clicking membership, go to my current sites. After clicking my current sites, ISET Robotics M1 2021 should appear there. When it appears, you click on it. After clicking on it, this is the first page that you will see. And for those of you who would like to see our past recordings, just underneath the UNISA logo, there are different types of tabs. Then you simply go to session recordings. When you click on session recordings, this is the tab. In fact, this is the page that you'll see. It's still loading for now. There we go. This is what you'll see. Our session recordings are available on the MOOC portal. The reason why we upload them here on the MOOC portal, it is because the MOOC portal, it is 0 rated. So we are trying to also help you save your data. Thank you so much. All questions are welcome regarding the MOOC portal. And if you are struggling to register, please don't hesitate to send an email on the i-set@unisa.ac.za. And on the subject line, just indicate MOOC portal assistance, and I'll certainly attend to you. Over to you, Dr. Gous.
Thank you. Oh, you're a tour guide. You're a born tour guide. There we go. Okay, but in the virtual space. So I was just, yeah, awesome. So part of what I was mentioning is about building passive attachments is you've got to get your learners to start thinking how things fit together. I've got a really thing called Crazy Contraptions. It's I don't know even know where I picked it up, but one of the really cool things is like you build this. This is a gearing, so it's like a coffee machine thing. But what I actually want to say is it's a whole lot of little pieces. Now I know that there are enough pieces here to make 7 of these. I know that. Okay. But what I do is I just give them a handful of pieces and tell them, okay, now you need to build this, but you're not allowed to take this away. So you usually have this in front of the class, and then they have to put this thing together. This is just a gearing with 3 axles and all the gearing mechanisms inside it. A lot of fun. Okay. Then the other one, which is really cool, it's just about ideas. And this guy has written a whole lot of these books with no words in it. It's like just lovely. So you get, and it shows you exactly how to do it. I'm not getting any commission on these books either. It's just that they work. All right. So if you have a 10-minute introduction, they've got to find the pieces and they've got to build these things. It's just basic mechanisms. Okay. So there's one on simple machines and there's one on wheeled wonders. Some of them have got motors on, which is more the WeDo sets for the grades 1, 2, and 3, but still very usable. And then fantastic contraptions. I've got a piece of I've got papers in here as well. So fantastic contraptions is just a whole lot of contraptions that you can put together, and then you get the learners to kind of build something their own, on their own. So one of the other books that I have is just a whole lot of ideas, also that's the one that I showed you on the screen. These are more powered attachments because they're attached to you can see you've got a motor on it. But I think what's important is how the attachment fits together. And so, yeah, you've just got to keep building. So you build this attachment to push things. You build a hook. The hook is not that straightforward because you've got to usually hook something and then pull it, and you've got to make sure it doesn't fall over or something like that. Can be a whole workshop in itself. Maybe we should add this to as soon as our hub is open, we'll have a oh, that's a good idea. We'll have a whole lot of volunteers and I'll give them a whole lot of building instructions. And then maybe for you that are a little bit further away, we'll show you what the progress is in the hub with our volunteers. But that is, yeah, and it's about building things. It's about building and understanding the principles and putting things together, and then because that is what you then apply. And yeah, you've got to build frames of reference. Building robots that are a little bit more complex, where they have their own designs. That's what you actually want. And so, like if you buy any robotics kit, whether you buy Spike Prime or EV3, you'll see there's a whole lot of building instructions. Let your teams build them. Get them to build them. The Riley rover, you should be able to build and dismantle, not break down, dismantle and reconstruct. 6 minutes. They should be able to build and rebuild something in 6 minutes. First with your building instructions, then you take the building instructions away, then they build it again, and then they build it again until they get how to put a thing rigidly together. Many years ago, the WRO competition, the learners had the design in their heads only. They were not allowed to come with anything, not even the wheel on the rim was allowed to be together. They had to lay it all out in front of them, and then the judges would go 1, 2, 3, go, and then you'd have 90 minutes to reassemble your robot. Maybe the timing wasn't great, but those learners in my teams certainly understood design and certainly understood how to put things together. Not haphazard, work with a plan, work with structure. Okay. This has been awesome. I'm really grateful. Tamela, I'm really grateful. We only have 3 members that are not on the MOOC portal yet. Yes. Have a fun time. The MOOC portal is open till the end of November, so please don't rush your portfolio. You've got plenty of time. And then you can submit it. But you are more than welcome also to ask questions. Send it to ISET, and Anzani or Tamela will then answer those questions as well. Okay. And on that happy note, okay, so I'm going to ask Tumelo, would you like to close the session?
Yes, Dr. Khosa, I'd like to close the session, but before I close the session, just to ask our participants, is there anyone who has a question would like to ask? This is your opportunity. You can raise your hand. There we go. Innocent, go ahead.
Hello everyone, how are you?
We are very well, Innocent. Very well.
I'm also good. Oh, I need to ask, ma'am, on the portal, which course do I start with first? The DBE 001 or the M1?
Okay. Are you a teacher at a school?
Yes, I'm a teacher, ma'am.
Are you from grade R to grade 3?
Yes, that's correct, ma'am.
Then I need maybe do the DBE 001 and DBE 002 first.
Oh, I need to do those ones first.
Yeah. There's no right answer to this, by the way.
Okay.
But I would say let's get those portfolios in first. Yeah.
Okay, yeah, all right.
And then you can come to another round of M1 discussions. And then yeah, and then you can just maybe then you'll see life differently.
All right.
All right.
Okay,
Excellent.
sure.
Excellent. Okay.
Any other question from our online participants before I close? Thank you once again for your question, Innocent.
That's really good.
Seeing that there's no one who has a question.
Nobody. I think everyone else is going to get their coffee.
Yeah, while our participants are going to have a 10 minutes break, I would like to take this opportunity to thank Dr. Khosa and the team for hosting us today. It has been a lovely session. Thank you so much for the questions from Angie and from Innocent. And for those who are watching this recording, thank you so much also for watching the recording. To our live participants, thank you so much once again, and a happy Thursday.
And we'll see you at 4 o'clock. Thank you.